In this video, we're going to do a concrete example of an FMEA of a park assist system, which is used in automotive slash motorsport slash trucking domain. We're going to see how SLIKWORKS can be used to actually create the FMEA for one such system. Starts off with creating a project. Once the project is created, then we go into the project dashboard. It gives us the option to do a bunch of things. For today, we're going to select an FMEA, and we are going to create a custom template over here. The custom template that we're going to choose is going to be very simple. We're actually going to make one. It's going to consist of 7 columns. There's going to be a component. There is going to be a failure mode. There is going to be an effect. There is going to be the cause. And then there will be a mitigation mechanism and then recommended actions. We're going to quickly go ahead and create this template. Okay, now that we've created this template, I'm going to select template number 2. So the template is selected. Now we're going to choose an architecture diagram. And once the architecture diagram is chosen, we're going to choose some existing effects and some safety measures. I'm going to quickly upload the architecture diagram and then we can quickly review the content of the architecture diagram. This is what the architecture is going to look like. Essentially, it consists of 3 ultrasound sensors placed at the rear of the vehicle, one on the left, one on the center, one on the right. All of this is connected to a microcontroller. The microcontroller sends a trigger to each of the um, ultrasound sensors to send out pulses. It receives the feedback and then it determines if there is an object in the vicinity. In order to operate the microcontroller, you need a voltage regulator, you need a flash, which is where flash code is stored. And if the microcontroller determines that there is something in the vicinity of the vehicle, then it informs the driver through a center display. The display is connected to the microcontroller using a display port. So this, in short, is the architecture. Now we're going to use this. This is a PNG file, and we're going to use SLIKWORKS to extract all the components and its signals. Here's a list of all the signals it's identified. You have the 3 sensors, you have the microcontroller, the flash, the voltage regulator, and the display. And it's also trying to identify the types of sensors, which is eventually going to use to predict failure modes. Next, we're going to effects. Under effects, we're going to add some known effects, which is coming from a HARA that we've already performed. and we're going to upload safety measures already from a TSC that we've already performed. So quickly, so we have all our effects and we have all our safety measures. So this is what the generated form sheet is going to look like. Um, it's going to first show up a bunch of all the components. Um, we can use this drawer button to expand on each component, or you can use this to expand all and collapse all. There is also the ability to filter using these columns, whatever you want to show, and an easy way to add safety measure. Simple example, let's take one. We can take the microcontroller here. If I open this, it has identified four failure modes. These failure modes are coming from ISO 26262 in this case, but this can also be from a predefined. Uh, it can also be from a predefined database, or there is also the option for AI to generate a failure mode. In this case, we've just used the failure modes from ISO 26262. And if you look at the instruction set failures, and if we expand this, then we go into, it has four rows. Each row is combined with each system effect. So we know there are two system effects. One is the loss of identification of object, and two is the unintended identification of object. So we have this ability, the tool automatically combines it with both the hazards, and it has also internally determined two causes that can lead to an instruction set erroneous execution of instruction set. One is a memory error, it's in the form of stack overflow or underflow, which happens when you're calling a function and then the stack memory is overflowing. But it could also be due to power supply issues, especially brownouts. Now, notice that the template that we are using over here is the new template, and it's not the AIAG VDA template. And all we want to do over here is to see if um, we have enough safety mechanisms to detect an error here or not. Now, in the trial version, the prediction of safety mechanisms is limited to a certain number of failure modes. In the complete version, it is possible to have all failure modes all safety mechanisms predicted. So in this case, we have a memory error, which is leading to hazard 01. Hazard 01 is a loss of identification of an object. The safety mechanism over here, from a safety concept, we have the following safety mechanisms.